Hi there, it's Mr. McAuliffe, and we are going to continue with part 2 of lesson 6.5, which is solving linear inequalities, and we're going to look specifically at graphing inequalities. So you can see the first part here I have taken directly from your book, and it says that all linear inequalities describe a region of a coordinate plane called the half plane. All points in the region are solutions of the linear inequality. The boundary line of the region is the graph of the related equation. So specifically, we're going to talk about how a graph of the inequality is shaded above and below, and some of the characteristics that go into it. When the inequality has a less than or equal to or greater than or equal to, then the boundary line is a solid line. When that inequality has a less than or greater than, then we have a dashed line. So you'll see that some of the graphs will have solid lines and some will have dashed lines. When the inequality is written with a greater than or equal to, the points above the boundary line are the solution, and that's where the shaded region takes place. And when the inequality is written with a less than or equal to, the points below are the solution. Okay. So here I have a table, looks very similar to the table that's in your book. It says when y is less than, we have a dashed line, and it's shaded below. When y is greater than, you have a dashed line, and it's shaded above. When y is less than or equal to, we have a solid line, and it's shaded below. And when y is greater than or equal to, we have a solid line, and it's shaded above. Next, we're going to go over 4 steps. I know your book only has 3 steps, but I've added the 4th, and they're the same ones we talked about in class. So graph the inequality. We want to do step 1 is to solve the inequality for y. We want to put that into slope-intercept form. So in some cases, it's already going to be y is less than or y is greater than, but if it's not, if it's in standard form, we need to convert it over and get y on one side by itself. Step 2 is we're going to graph that boundary line. We're going to use a solid or a dashed line, and just like we would graph an equation, we are going to graph the inequality. Step 3 is we're going to determine whether or not we're going to shade above or below based on the inequality symbol. And step 4, which is probably the most important, is we're going to check to see if your solution works. We're going to pick a point inside the shaded region, and we are going to see whether or not it makes the statement true. So let's take a look at a couple examples. I have y is less than or equal to 2x minus 3. So the first thing I'm going to do is go to -3, plot a point. That's my y-intercept, and then I'm going to go with my slope as 2 over 1. So 1 over and 2 up, plot my point, 1 over, 2 up, and continue to follow that path. Okay, I'm going to go in the opposite direction also, 1 over and 2 down, in order to make sure that I have an accurate line. So now I've got this in. Step 1, I already have it into slope-intercept form. Step 2, I've kind of put my image of my boundary line in. Now I got to see, is it a solid or a dashed line? And because it's y is less than or equal to, I'm going to have a solid line here. Let's see if I can draw as best as I can here with a solid line through those points. And now I'm going to look at it's less than, so I'm going to be graphing this below. So I'm going to shade this, let's see here, everything that's below the line in terms of my solution. Okay, and then I'm going to pick a point. Any point will do, and I'm going to pick this point right here. So 1, 2, 3, 4 comma 0, and I'm going to plug it in. So 4 times 2 would give me 8. 8 minus 3 gives me 5. So y would be 0. So is 0 less than or equal to 5? Yes, it is. So that makes that statement true. That part of it is true. So that's an example here. Okay, so looking at the second example here, we have 5x plus 2y is greater than a -8. So I want to start by going ahead and changing that over to slope-intercept form. So I'm going to rewrite my equation. 5x plus 2y is greater than a -8. Then I'm going to subtract 5x from each side and rewrite it as 2y is greater than a -5x minus 8. And then divide both sides by 2. And now I have it into a format that I can graph. Y equals a -5 halves x minus 4. So I want to graph this. I have a y-intercept of negative 4, so I'll plot a point. And then I'm going to go over 2 and down 5. 1, 2, 3, 4, 5. Plot my point and then do it in the opposite direction. And so on. So now I've got a situation where I've plotted my points on here. I've done step 1, step 2. Now I'm looking at what type. Do I have a solid or a dashed line? And because it's greater than, I'm going to have a dashed line. So I'm going to try to connect the dots here as best as I can with a straight line. And I'm going to look at shading it above because it's everything that's greater than. So it's going to be this whole region here that's shaded, which will make things a little bit easier when we test it out here, because I can choose the origin. That's the easiest spot, easiest coordinate to choose. So I'm going to plug 0 in, and I'll get 0 plus 0 when I do my multiplication is greater than a negative 8. And that is true. 0 is greater than a negative 8. So I know that I've graphed the right part of it. And that is how we go through graphing inequalities. Step 1 is make sure it's in slope-intercept form. Step 2 is to graph our boundary line. Step 3 is to determine whether or not we have shading above or below it. And step 4 is to check our answer. Thanks. I hope that helps you out.